All right, so let's jump into things. So welcome everyone to TigerGraph 101, an introduction to TigerGraph. My name is Dan Barkis, and today, hopefully, I will be giving you everything that you need to know to begin to build your own TigerGraph solution. So we're going to kind of walk through the process of creating a demo solution. We're going to look at what kind of format our data needs to be in, how to load it in, how we kind of set up our schema. And additionally, from there, we'll look at some of the cool graph queries that we can write to gain some insights about our data that we would not have been able to see before. So like I said, this will be an interactive demo. So the first thing that you'll need to do if you want to follow along and participate is create an account at tgcloud.io. This is our TigerGraph cloud provider where we allow you to create cloud instances of TigerGraph. You can do it completely free. So with every account, you get a free tier subscription, meaning you get a free instance that you can just spin up and use however you want. So for that, we'll all be using a free tier instance for this demo. But if you can just go ahead and create the account, you'll need to confirm your email address. But other than that, it should be a pretty quick process. So while you're doing that, I'll just introduce myself very briefly. Like I said, I'm Dan Barkis. I'm a developer advocate here at TigerGraph. I've been working here for about 6 months, but I've been working with the TigerGraph product for probably about 2.5 years now. Worked with it a lot at my last job where I did a lot of healthcare work, looking at claims data and things like that within kind of a graph context. I have a background in sort of random electromechanical engineering stuff, like to tinker and build things like that. So that's kind of a little bit of where some of this will come from. But what you're really here for is to learn about graph databases. So we'll just jump into the fun stuff. As kind of a precursor, let's take a look at the way that we do things now with sort of the relational setup that a lot of us are probably familiar with, our SQL databases and whatnot. So if you recall, we have you have tables, which are made up of columns and rows. Each table represents like a data concept. So in this example here, we have a table for product, we have a table for order, table for supplier. And within that, each row represents a unique entry in that table, and each column represents a type of data that that table has. So for example, our product might have columns for product name, product price, product quantity, and each row would represent a unique product within that product table. And that's great and all for a lot of things when we need to kind of, when we don't care about the connectivity of our data, when we're looking to just store it and be able to quickly relate things or access things, this works out for us. But where this starts to get complicated is when we want to start joining those tables together. So if we wanted to say, take a look at what locations people were ordering a specific product from, well, we need to take our product table, we need to join that to our order table, we then need to take our order table, join that to our location table, and we need to pull back all of these connections. And the issue with that is that while it works, we're generating these connections at query time. So every time we run this query, we essentially have to rejoin these tables, rerun those connections, and establish what we're doing from there every time we run it. Graph, on the other hand, kind of flips that on its head. So while the idea is similar, you don't have tables with rows and columns, you have types of vertices that then have individual vertices which have attributes, but I'll get to that in a sec. But the main core of graph here is that instead of computing those joins when you are running your queries, those joins are pre-computed when you load in your data. So the native relationships between these types of data are already in your database when you begin loading your data. That's what your schema is. The schema is the way that your different pieces of data relate to each other. And by having that set in stone when you begin, it means that now when your queries need to use that information, instead of having to do all that work of joining every time, they can just traverse those joins, which already exist. So I'll explain that a bit more. But like I said, graphs are made up of nodes, and those nodes are analogous to our tables in a relational database. So a node represents a certain type of data. In this case, we have a customer. And then that node, that vertex type will also have vertices in it. So each one of those vertices is a unique entry in that type. So it's analogous to the rows in our table in a SQL database. And then additionally, each one of those vertices can have attributes, and those attributes will help describe it. So something like a customer might have a customer name, a credit card number. something along those lines. And those are analogous to the columns in our table. So you can kind of see here how at a core, the representation of the data is more or less the same. It's just the way that we're structuring it and the way that we're connecting it. So the big part here is edges in graph. So we have these vertices, but the value comes from how they are connected to each other. And this is, again, analogous sort of to our joins back with our SQL database. So in this situation, we have a customer and they reside in a location. Customer resides in location. So normally this would be a join between a customer and a location table. You'd have to find the primary ID of your customer. You'd have to find that in your location table, and then you'd be able to say where your customer lives. However, with graph, that's all just computed as an edge. So that already exists once you load in your data. You load in customer and it says, oh, they need a location to live at. So it finds the location in your data file, and now they're linked up. So now you don't need to say join customer with location. You just say find the location that my customer lives at, and the graph backend will take care of the rest for you. And what this allows us to do is now, instead of having to, now if we want to ask a complex question, instead of having to go through the process of writing this complex join heavy query in order to answer that question, we can just traverse these edges as if, as if they're part of the data. So it's literal pointers in memory addresses. So it's blazingly fast to just traverse these edges. And because we've already created them through our schema, they already exist. And now if we have a query that we want to write, we don't have to worry about, what joins do we need to create, because everything's already there. So more specifically, we'll be looking at property graph. So property graph just describes the ability of both vertices and edges to have attributes. So that means that our payment has a transaction amount, our order has a quantity, we have a date on the edge that represents when this order was paid for, and whatnot. So that really just allows us to much more easily traverse our information. And additionally, because there's these connections, these logical connections where this data relates to each other, it allows us to explore our data in ways that we couldn't before. Because instead of now having to find the question you want the answer to and write a query to solve that problem, with those complex joins, you can look at your data now, how it's already related to each other, and sort of pull information out of that. And we'll get to that. You'll see that when we start doing our demo. But for now, really the core to take away from this is that vertices are connected by edges. Edges represent relationships between vertices, and vertices represent concepts of data. So order, customer purchases order. So the relationship between order and customer is that the customer purchased it. Order ships to location. That's the relationship there that we're trying to represent. So some of the real world use cases where this is really helpful, supply chain analytics and management. So if you think about it, the answer right here is kind of in the description, supply chain. A chain is a link of all sorts of different, it's a bunch of different links that make one big object. And that's what graph is essentially, is it's a bunch of vertices that are connected to each other with edges in order to gain more insights. So supply chain is something that can easily be tackled. You take a look at your different suppliers of something, the different manufacturers, how they ship between each other, then those possibly go to storage facilities where they're stored there, then they can go out to an assembly plant where they're put into a final product, and then they get shipped out to a location. So we have all of these complex interactions between these different entities, and being able to keep track of them would really allow us to help manage our supply chain better. We can say, oh, supplier A isn't able to meet our demand, but we have supplier B over here who can meet half of our demand. So let's pull in, let's order a little bit from supplier A, a little bit from supplier B, so that way we can meet the demand that we're actually looking for. Things like that, where you can view the propagation of decisions up or down the supply chain due to those inherent connections that already exist. Fraud detection is a similar kind of approach that can be taken a lot with banking fraud. Is really a lot of it looking for money laundering rings. So typically you'll have these transactions of money within a set group of people. That's the laundering ring that it's going through. And now if you can identify with graph, you can take those transactions, you can take a look at who they are sending money to, the quantity of that money, and you can now link that together. So we can see person A sending money to person B, person B sending money to company B is paying person C, and person C is paying person A that same amount of money that they initially put in. So we can see there that that most likely is some sort of money laundering ring just due to those connections of how those transactions propagate out. Obviously, that's a very simple example, and the world is much more complex than that, but that is what graph is for understanding that complexity and breaking it down into something that is human understandable and able to be easily traversed through the graph queries that we can write. And kind of another one of our big use cases is sort of user journey or customer 360 type use cases. So if I'll take a healthcare example here. So you're a healthcare company. We have a lot of different interactions with the healthcare system as people. You know, I can go to the doctor, I can go to the dentist, I can call my doctor, I can schedule an online appointment, have a telehealth appointment, I can, you know, go to an urgent care facility. So there's all these different touch points that me as a person can have. And then further from those touch points, there's all this stuff gets spun off of it. So anytime I go to the doctor, now a healthcare claim has to be created. And that claim has to go through a complex system within the healthcare system in order to get processed and validated and everything. So each one of these touch points not only is just somewhere where I have to interface, but now there's this whole back end of processes that's spun up just from that interface that I have had. So how do we tell what each user's interface looks like and how those different processes are affecting it? Well, with Graph, we can easily make that relationship between user went to this healthcare facility, that healthcare facility created these claims went to this payer, or they caused a spin-off of an order for this prescription. That prescription then gets mailed to the user. So now all of a sudden we have all these different touch points that we need to keep track of. And natively within Graph, that's very easy to do because those connections are already there. And as you load in more data, those connections are created because they're part of your schema. So you can get a much better view of the holistic situation. This is just a little bit more info on some of the use cases. Like I said, supply chain is very inherent just due to the relationship of all these different parts that make up of things and all the different stages in manufacturing that they have to go through. There's all these different, once again, touch points that you have to keep track of and how they relate to each other. So being able to do that with Graph gives you a lot of value. Healthcare, or patient journey, once again, just kind of multiple interactions and being able to identify things like gaps in care that you may not have been able to see before can be very valuable for your patients. So let's get into what we'll actually be doing. This is where I think I'll have you all hop over to TG Cloud. We'll create our solution just because it's going to take a couple minutes to spin up. And while that's spinning up, I'll walk through what we'll actually be creating. So what we'll want to do is head over to TigerGraph Cloud. So that's tgcloud.io. And you'll want to log in there with the account that you created, hopefully during the beginning of this session. And then from there, you'll want to click down to the My Solutions tab on the left. Yours will be blank, won't look like this, but that's what we're going to fix. We're going to create a solution. So in the My Solutions tab, over on the top right, we have a blue button for Create Solution. You'll want to go ahead and click on that. Now, one of the cool things that TigerGraph does offer is we have a bunch of built out, pre-built solutions with data and queries already in them. So if you wanted to explore something like a movie recommendation engine or some startup data, some fraud detection, then we already have these types of solutions built out. You can just click on any one of these and it will spin up your graph for you. But we're doing things by hand today. So we'll be starting with a blank graph. So we'll pick a blank, and this will just be the most recent version of TigerGraph. So 3.2 is what we'll be using for this. Go ahead and click Next. And then here, you will just select your cloud platform. Doesn't really matter. They all provide exactly the same TigerGraph service. And you'll want to select TG Free for your solution because we'll be using the free tier. All of this will remain default. You can select a region that's closest to you if that matters, but realistically, you're not going to see any performance impact, for at least for the sake of this demo. You'll be limited to 50 gigs as your disk size for your free tier, but that will be more than enough for everything that we'll be doing today. So next we'll click Next, and that will bring us over to this page here where we set up some more parameters of our solution. So the first thing we'll want to do is give it a name. This will just be the name that's displayed within that solutions list when we go to look at it later. And additionally, we will want to set up a password. By default, this is TigerGraph, all one word, all lowercase. I'm going to leave mine as that. And the most important bit here is the subdomain. So this is the location that you will actually access your TigerGraph solution from. If you leave this blank, it will create a big random string of numbers and letters that is not at all easy to memorize. So I would recommend putting a name in here, just so that way you have something handy that you can remember when you go to access it. Lastly, you'll click next, and that will bring up this summary page, which will just have a rehashing of all that information that we just looked at, so you can confirm everything. And then you will go ahead and click submit at the bottom. I'm not going to do that because I already have one set up, but go ahead and click submit. And what you will see is your solution begin to appear. And then your dot here should be yellow, and it should say something like spinning up or setting up. And after about 3 to 5 minutes, it will turn green with ready, and we'll hop back into it. So while those are spinning up, let's get into a little bit about the graph that we'll be building. So we'll be building a very basic social media type graph, and it's going to consist of people, and those people are going to create posts, and they can also like those posts. Those posts will have hashtags, which will kind of describe the content of those posts. And additionally, the people can send messages back and forth to each other. So the person has the ability to send a message, and they have the ability to receive a message. And then the message entity is its own vertex. So one of the quick things I want to cover here is sort of why we ended up on this schema design. So the first thing that we want to take a look at is what we're trying to represent. So let's hop on over to our data and see what we have there. So this is the repo that we'll be using. The link to this repo is in that link that was sent out at the beginning, and we will provide a link as well. But as you can see, we have 4 data files: likes, messages, posts, and users. So let's just take a look at our users file and kind of see how that's structured. So we have a identifier, unique ID. We have an email address. We have a username, and we have an actual name. And then lastly, we have a join date. So this is just a standard CSV file. You'll mainly be working with CSVs when loading data into TigerGraph, but you can also load from JSON as well, or you can load directly from something like a Kafka stream. So there's all sorts of different ways to get data into TigerGraph, but for the purpose of this, we'll be dealing with CSV files where each row represents an entry into our graph. So this is the basics of our users file. And then additionally, we will have ones for posts and messages. I'm not going to go too into depth about these. The posts have long sections of content in them, and that will be something that we'll have to deal with when we load in our data. But they also have a posted date, who posted them, whether or not they've been deleted, and up to 4 different hashtags. So from that, what we want to take a look at is what are the core entities? What are the actual nouns, more or less, that are within our data? So we had our people, we had our posts, we had our messages, and additionally, we have these hashtags. So when creating a schema, you want to take a look at that. What are the entities and what are their relationships between each other? If you have an entity, something that you recognize as, this is a thing, that should be a vertex. If you have a way that it can interact with another type of thing, which is described by your data, that is an edge. Anything else that just describes any of those entities will be an attribute for that entity. So for example, person will have our email address, username, full name, and join date, because those describe that person. However, the one caveat there, so posts, for example, you would say, then why isn't hashtag? Why isn't that an attribute? That describes the post. Well, the thing here is, for this, these hashtags are important. We want to be able to sort based off of our hashtags. We want to say, find me all posts that have this particular hashtag. So any attribute that you are going to filter on or plan on filtering on should be a vertex. So in this case, the post has those hashtags because we want to be able to sort by those hashtags later. We want to be able to say, find me, all hashtags that this person has posted, or I want to say, find this specific hashtag, find all posts that contain that hashtag, and then find all people who made any of those posts. So because we want to filter on that, we want to separate it out as its own vertex. And then This is just kind of a breakdown of what we'll be looking at in terms of the vertices and edges. It's just this representation, but I've added in the attributes as well. So we can see person has email, username, name, join date, and so on. So that's great and all, but it's a little confusing in the way that it's laid out right now. And I think that this will make a lot more sense once we hop into our actual graph. So we'll see, hopefully now everyone's solutions are saying they are ready. And then over here, you can see that there are these 4 boxes, with one of them a little bit tilted. And if we click on that, we can click on GraphStudio, and that will launch our GraphStudio interface. And we can see here that the URL is the same as that subaddress that subdomain that we created earlier. So if we wanted to access this without having to go through the cloud portal here, we could just go to tg-101.i.ggcloud.io, and that would bring us to this particular solution. Make this a little bigger, actually. There we go. So the first thing we want to note here is that right now, in the top left corner, we can see that we are in the global view. There is not currently a graph created, and that's fine for our use case. That's perfectly fine. So just something to note, though, is that we do not have a graph right now. We are just working with our global schema. So because of this, TigerGraph has the ability to have multiple graphs per solution. So we could have 7 different graphs, however many graphs we wanted on this particular solution. The global schema is a global schema that we can pull from for any of those graphs. So say we had a graph that was representing, let's say, our social network, the one that we were just talking about. So we have those people, posts, messages, and hashtags, and that's the core of a lot of our graphs. So we want that to be our global schema, because we're going to then create, maybe 2 graphs, one for looking at exactly that, and then one for looking at that data, but in relation to some other data. So we will be able to inherit as much or as little as this global schema as we want into any downstream graphs. And then those downstream graphs can each have their own unique changes to their schema. So really, this global schema is just saying, you can use this across any of the graphs that you create. You don't have to, and you don't have to use all of it. But if you want a consistent schema across your graphs, then you want to create it in a global space and pull it into each graph as you create it. So that's just a little thing there as well. And something I want to say as well, because I'll be doing it to save some time with this demo, is that anything that you can do through this GraphStudio interface by clicking around can also be executed via code. So clicking around is a great way to get familiar with the interface and to understand the concepts of graph, but obviously in a production situation, you don't want to have to be going in there and dragging around vertices to create your graph. So anything that is being done in here can also be done via code, and I will be showing that in this demo as well. But let's get on to it. Let's start building out our graph. So the first thing that we'll want to do is head over to this Design Schema tab right now. Within the global view, that is the only tab you will be able to click, because the rest of these are related to specific graphs, and we don't have a graph yet. We just have our global schema. So we'll click Design Schema, and then we'll click this plus icon up here to add a global vertex type. So this will be our first type of vertex. And if we recall from looking at our data, we need a person. So we'll create a vertex we'll call our vertex person. And then additionally, we will specify our primary ID. So here's something to note here. For each vertex has to have a unique primary ID. Just like a row in a SQL table, each entry has to have a unique primary ID. This is no different. The only caveat here, we'll see that we have this checkbox here called as attribute. So the primary ID of a vertex cannot be accessed from within a query. The primary ID cannot. It's merely there just to differentiate that vertex from all the other vertices. So by checking as attribute, what this does is it creates basically an attribute within our vertex that contains that primary ID as well. So now we have the primary ID, which will be used for sorting and filtering and making sure that that vertex is unique. And then we have duplicated that ID as an attribute within our vertex. So now we would be able to see that ID from within the context of our query. So if I wanted to select a bunch of vertices and then get their primary ID, I would be able to do that with it as an attribute. If you don't care about the primary ID, like for example, I'll be loading in messages, those have a primary ID, but I don't care about that primary ID, then I don't need to click as attribute, because that ID is merely there for them to be unique within the context of the data. It's not something that I ever care about. So if we remember our person, actually, first let's get to kind of this fun bit. So the vertex here will be shown as it's described here. So you can just kind of change the color as you want. So if we wanted our people to be, I don't know, blue, we could do that. And then we could select an icon as well to represent them. So that way, once your graph schema does start to get complex, it can be very easy to differentiate your vertices from each other just due to these icons. So that can be very helpful as we go on. Let's just take a look at what our fields were again for our person. So we had email, username, name, and join date. So we'll add these in. So email, and then additionally, we will select type string because that's the type it is. You can see here we have all your sorts of basic data types that you can choose from. And additionally, we could choose whether or not we want to index this. We will not be doing that for these. We just don't need to. Additionally, you will also be asked if you want to specify a default value. So all of these attributes, all of these types, sorry, have a default value already. So for integers, it's 0. For strings, it's an empty string. But if you wanted a different default value than that, then you could enter that in here. So I guess first I should specify in graph, there's no such thing as a null. Everything has to have some sort of value in its place. So if you go to load in data that does not have a value there, for example, if this user did not have an email address, we can't have null in our database. So what it will do is enter in the default value for that particular data field. So if we didn't have an email address for this person, we loaded them in, it would say their email address is just an empty string. So let's just go ahead and add in the rest of our attributes here. So we have our username, which is also a string, and we had the name, once again, a string, and lastly, the join date, which is a date time. There we go. Then we can just click this check mark up here to add that vertex to our graph. So now we have our person. Great. So let's add in another vertex, and then I'll show you how to make an edge, and then we'll use code to just fill out the rest of the schema, because as you can see, clicking through this isn't exactly the most exciting thing to watch. As much fun as it is for me to do, I'm sure that you would not want to sit here watching me do this all day. So we'll add in messages now. And our messages, let's just take a look at what we are representing there. So our messages have a subject and a body. So we can go ahead and add those in as well. Otherwise here, primary ID, like I said, for messages, that ID is just so we have a unique identifier within our data table, and we don't actually care about that. So we will not check as attribute there. So let's add body as a string, and subject as also a string. So there we go. So now we have two vertices, two vertex types rather, a type for a person and a type for messages. So let's create some edges between them. If we go up to the top, we can see that there's this arrow here that says add global edge type. And we'll click on that, and now it's turned blue. And we can click on our person, and we can click on our messages. And now we have an edge. This is where things start to get exciting. So these edges represent the relationships between these two types of vertices. So in this case, our person can send messages and they can receive messages. So we'll do sent message. Now, something to note here is we have this checkbox that says directed. This is important. Relationships can either be directed or non-directed in graph. And that means whether or not they can go both ways. So for example here, our person sends the message. The message can't send the person. That doesn't make any sense. So therefore, this is a directional edge because the person sends the message. The message does not send the person. It goes one way. The caveat here, though, is that now, as you see, when I click directed, we get this additional section down here asking of us about this reverse edge. So the caveat is that when we are writing a query, we can only traverse an edge in the direction that it goes. So if I wanted to go from person to message and I had a directed edge, then that's perfectly fine because the person sent the message, so I can go from person to message. However, if I wanted to go from message back to person, and this was a directed edge, then I would not be able to do that because the edge is not facing that direction. So that's what this reverse edge section is here. This will create essentially a second directed edge going in the opposite direction. So that way, when you do write your queries, you can traverse in either direction. You could not create this if we didn't want to be able to go from messages back to person, then that's perfectly fine. But in our case, we want to be able to go bidirectionally for all of our queries. However, we still want to maintain that this is a directional relationship because the schema here should describe the data itself, not necessarily how we plan on using it. The relationships are inherent to the data. The use case that we are trying to solve for is something that we write queries for. So we want to represent our data as accurately as possible, and that's why this is going to be a directed edge. Now, additionally, we can style that edge, and we can also give it attributes. So our sent message edge does have some attributes. We have the person who it is being sent from, the person who it's being sent to. Actually, those are the, sorry about that. Those are the vertex types that we're going from and to. So something specific to note here is an edge has to go between two vertices. You can't have an edge that is only connected to one vertex type. That's just, it can't exist. So you will note that we do have a source and a destination vertex for each one of those edges that we do create. Sorry, that had the attributes of to user and sent time. So we will go ahead and add those as well. Attribute name to user, say string, and then sent time is a date time. And there we go. So now we've created our edge. We can see that we have an arrow here, which tells us that it is a directional edge. So we can imply that person is sending a message or is sending a particular message. So now the person can also receive a message. So we can once again go through the same process. We click our little arrow up here to add a global edge. We click on messages, and then we click on person. We want it to be directed, and then we can call this received message. And we could additionally add our attributes in there. I'm not going to go through the process for that. And in fact, we're not even going to save this schema because I'm going to go ahead and do all of what we just did, but through code with one or two simple steps. So one thing to note here, though, if we did want to save our schema, you will need to click this publish schema button in the top left corner, and that will effectively upload your schema to the TigerGraph server. Right now, this only exists within the browser context, so you will need to publish your schema for it to actually be represented on your server. So what I'm going to do now is I'm going to hop into a Google Colab notebook. This is additionally linked in that document that was sent out at the beginning of the presentation and will be sent out at the end of the presentation as well. And we are going to use our PyTigerGraph driver. So we'll be using Python right now to interface with our TigerGraph server. We have drivers for Python, JavaScript, and Java currently, but it's not limited to that. Everything that is done through this interface is done via REST endpoints. So all you have to do is call those REST endpoints. If you're using a different language, as long as you can make REST calls, then you are good to be able to interface with TigerGraph. So the first thing we'll do here is just set up our connection. I'm not going to get too in depth in this, so we do have videos on how to use PyTigerGraph. But basically what we're doing here is we're putting in the domain of our actual TigerGraph solution, and we're putting in our username and password, which we have set. And then we are creating that connection using those specified username, password, and location. So we can see now that we've connected. And this line down here is our actual schema. So if we take a look at this line, we'll see that we are creating vertex person. So we're creating a vertex, we're calling it person. It has a primary ID called ID, which is of type string. And then it additionally has the attributes of name, email, username, and created at. And those have their data type following them. So we can see that this is exactly what we did through that user interface. We created a vertex called person with these set attributes. And then we're also saying that the primary ID is an attribute. So we're just specifying that as well. And then if we were to take a look at our edges, we can see here, create directed edge. So create an edge with direction, sent message, which goes from a person to a message and has these attributes of toPerson and sent date. And additionally, it has a reverse edge. So like I said, this all looks familiar because these are the buttons we clicked in the interface, and this is just what that looks like as code. So if I run this, we'll take a second just to get our initial connection in there. But what we'll see is that once this is done running, if we go back to our design schema page and I hit refresh, then we will see a fully populated schema in there because we are creating that schema through these blocks of code. We'll just let it, there we go. So we can see that all of these have been created. And if we head back to our schema and refresh the page, there's our schema. Pretty awesome. So that's what we had before. We have our messages, we have our posts, and we have our hashtags. And this should look pretty much identical to this slide here. Funny how that works. So that's kind of the basics of creating a schema. You can do it either through this user interface where you create your vertices and edges by clicking and sort of setting everything up that way. Or if you're going to be, spinning this up a lot, or you are just someone who would rather interface with code than with the UI, then you can do that through code as well. And we have some great tutorials on how exactly to do that. So the next thing that we'll want to do is actually create our graph. So remember, like I said before, this is our global schema. We're not in an actual graph yet. So what we can do though, is click where it says global view, create graph. And we will call this one my graph because we are creative. I believe that's what it's called. Yep, my graph. So from there, we will then say that we want all of the vertex types and all of the edges from our global schema. We don't have to select all of them. We could at any point pick and choose. Like I said, if we were making a graph that just had a subset of the schema, we don't need everything. Then we'll click create. Oops. This will take a couple seconds and it will create that graph for us. And what that will do is, in addition to creating that graph, it also creates all of the endpoints for that graph. So like I was saying, everything that you can do here can be done via REST endpoints. So when that graph is spun up, those endpoints are created, and there's a bunch of built-in ones that will give you stats about the graph, information about the data that's been loaded, how much data has been loaded, all sorts of things like that. You can check those out in our documentation. We have a link to a list of sort of all of the built-in REST endpoints that you can pick and choose from when you're building these solutions. So there we go. So we can see that we have created our graph. And now what it has done is we've switched over from our global view. We are now in my graph. And we can see that same schema that we had before, except it's a little different because there's these globe icons on there. And those globe icons, guess what they mean? That's a global vertex type. So like I said before, we're not limited to just our global schema. There's nothing preventing me from creating another vertex in here. And now you'll see that this vertex does not have the globe icon on it. So it's not within the schema. It's only within the context of this graph. But we're able to do that. I could link this up with edges if I wanted to, any of our pre-existing data. And there's nothing wrong with that. So you can have a completely unique schema within any one of these graphs, or you can pull as much or as little from your global schema as you want. But that is just the schema. So let's get into actually putting our data in the graph. So what we'll want to do is head down now to the Map Data to Graph tab, and we'll want to head over to our GitHub repo where we will download all of our data. So I'm just going to grab this as a zip file. And we can go ahead and open that up and see our data files within there. So what we'll do now is head back to TigerGraph. We'll click Add Data File in this top left. So it's the file icon with the plus in it. Quickly upload file to server. Then we'll go ahead and find our folder, all of our CSV files, and we can go ahead, select all of them and hit open. And that will just upload all of our files at once to our server. And clicking on those files, we will get a little representation of what those files look like. And there's some things that we have to do in here just to make this friendly. So we can see right now that our header is being pulled in as a line of data. So we can go ahead and select as header. And what that will do is just remove the header and give it to us as a header. So that's not going to be loaded in as data. And that's all we need to do for this likes file. But this messages file looks like an absolute mess right now. And that's because it's a poorly formatted CSV. And I did that on purpose to show you some of these things here. So the issue here is that we have some commas within our paragraph of text, and the comma is set as our delimiter within our CSV. So it's breaking that text into separate columns as it sees those commas. Now the text is wrapped in quotes. We can see those quotes here. So all we have to do is change our enclosing character for our CSV to quotes. And we can see now that all of our text is behaving nicely. And additionally, this has a header. So we'll go ahead and select that as well. So that's just some of the options that you have for the ability to be flexible with your CSV files. You can choose your delimiter, you can choose your line characters, your enclosing characters, and as well the format of the file. So now, while we did load this by just uploading these files to our server, you can also pull them in from an S3 bucket, or like I said before, you could hook it up to a Kafka stream. So let's go ahead and add one of these files to our data, and we'll go ahead and map this file manually. And then again, I'll go through this in code because you don't want to watch me map all of these files. So here we have one describing our likes. Actually, I'm going to start with a different file. So we'll start with the posts file. Once again, I'll need to set our enclosing character. We'll need to just choose that it has a header, and we can click add. So posts directly describes our posts. So what we can do is we can take these crossed arrows up here, map data file to edge or vertex, click on our posts file, click on our post vertex, and now we start seeing some mapping. So we have columns ID, content, posted date, and deleted. What we can do is just click on our ID, that corresponds to our ID. We can click on our content, that corresponds to our content. And one of the nice things is if you're building a demo from scratch and you have the ability to name your attributes and your data file, you might as well name them the same thing. And then we can click this handy light bulb icon up here, which will automatically map the rest of our data based off of the names of those attributes and the names of those columns in our data file. So essentially what this does is it says, this is our CSV, and these are each of the columns in our CSV. And for each one of those columns, they represent this attribute or this part of the vertex. So our content is the content of our vertex. That's the paragraph that says what's in this post. The posted date, once again, is the posted date, so that's linked up like that. And that's just what these linkages are doing. Where this can start to get a little complicated is when we do edges. So let's go ahead and do one of those right now for our posts. Or actually, we'll do that for likes because post is a little bit more complicated. But what we have here, so you'll remember with every edge, we have a source vertex and a destination vertex. So those are two things that we absolutely need. Without those, we cannot have an edge. So those are our main two things within our edge. Our source vertex is where it's coming from. So in our example here, that is the by user. So that is the user ID of the person who liked the post. And then we also have liked post, which is the post that they liked. So we're going to link that to our target vertex of post. So our source vertex of the person is linked to the user ID of the person who did the liking, and the ID of the post is linked to the ID of the post. And then additionally, linked date is our attribute, and that will be connected to our like date as well. So that's fairly simple for an edge. It's really all we have to do is we have to say where it's coming from, where it's going to, and any attributes that we have there. So what will happen now is when we created those posts, you remember we had that ID. So those posts have that ID. So now when we add in these likes, for example, here, liked post 798. So this will create an edge between person 65 and post 798. And that edge will be a liked edge because that person liked that post. So this is the basics of setting up your schema through this interface. Just like with setting up your data mapping, just like with the schema, if you were to click this publish data mapping button right here, that would publish it to the server. Like I said, we're going to be doing this bit through code. So I'm going to go ahead and do that now, just because you don't want to watch me do the data mapping. So the first thing I'm going to do is clone our data into our notebook. And then from there, I'm going to set up the loading jobs. And basically, these do just what I was doing by hand. It says map a data source to vertex. So for example, we did, we linked up posts. So it's saying vertex posts. And then this values bit here, looks confusing, but this is actually referring to your input data file. So in our case, that is our CSV. So we can see these numbers represent the column numbers of that file. So column 0 is our first column 1 is our second column, and so on. So we can see that within our post file, column 0 is that ID. Sorry, I'll do that through this interface. Column 0 is that ID. Column 1 is our post content. Column 2 is the post date, and so on. And what we can see there, though, if we look at those numbers, is that we're linking column 0, 1, 2, and 4. If we look back at our data, we have 0 is going to our ID, 1 is going to our content, 2 is going to the posted date, and 4 is going to the deleted. So that's kind of what this file looks like and what those numbers represent. It's just the column numbers and how they map to each individual attribute within that vertex. So we'll go ahead and do that. So we ran that, and that will create our loading job. I already ran it, so it already exists. And then what we can do here is actually load in each one of those files. So this will just load in each one of those data files. Sorry, these just create the those individual loading jobs for each file. There we go. This is the part that will actually do the loading. So if we go back and we refresh, we will actually not see any of this data mapped within this view. And this is because we didn't map those data files within this view. We did it via code. So just one caveat there is if you do the mapping via code, it will not show up sort of in this map data to graph category. But what we can do now is go ahead and load all of the data. So we'll just run each one of these files. Or we would if authorized for URL. Posts. Always fun when the demo doesn't work. But we shall see what is going on there. Authorize. All right, well, we will pivot then. So what that would look like, let me just load up one of the ones. This is unfortunately gonna affect the queries that we'll be writing, but we'll see if we can do this on the fly. So let's link up posts again really quickly. And go ahead and publish that. There we go. And then what we could do is, normally we'd see this, but you'd click on to the load data tab. You'd have all your different data sources here. They'd all be mapped up nicely if it had all worked out. I'll take a look at that and see what's going on. But then we'll click the play button up here. And what that will do is load in all of this data that's in any of those CSV files actually into the graph. So we'll see that vertex count. We'll see it only go up for person because that's all we have, or post rather, because that's all we have mapped right now. And then you'll also see our graph of the number of vertices begin to increase. I'm just going to take half a second here and try and troubleshoot what's going on, just because it would be very helpful if we had all of our data in the graph for when we write our queries. Oh, I know why. So this was all my fault. So before, when I created the graph, when you create a graph, you need to re-authenticate when you connect to it, because when you have just your global schema, all you can modify is the schema. But once you have a graph, you can actually have data in your graph. So you want a more secure connection to ensure that no one is just going in and modifying that data in your graph. So what I had to do here was create a secret on the graph server, which then creates a token. And I can use that auth token to then further authenticate with my graph. So the issue is before I was trying to insert data into my graph, but I was not properly authenticated. So it was not letting me do that. There we go. Now that we're authenticated, we can see that our data has in fact been loaded. And I should actually finish creating our, never mind. So yeah, we can see that our data has been loaded. We loaded in 1001 lines of data from this posts file, and we'll just go ahead now and load in the rest of these data files. There we go. So that will load in all of our data, and we can see here that our graph, or our chart rather, representing how much data is in our graph is spiking as that data is being loaded, and these numbers are being populated as well. So once that stops going up, we'll be able to explore our graph and see what we have in it. So this Explore Graph tab, I'll breeze through this really quickly because I do want to get to queries. But this Explore Graph tab does have a couple of different subtabs within it, and these allow you to just look at your data in different ways. But we'll start with this first tab here, which allows you to either find a specific vertex by its type and ID. But the thing I use it for most usually is its ability to just select a random number of a certain type or all of your vertices. So in this case, I'm going to select 5 random person type vertices from our graph. We're going to click on that. And now we have 5 random vertices. If we hover over them, we can see the attributes of each vertex. So we have their name, username, email address, and the date time that the account was created at. And additionally, here's where stuff gets cool. We double click on any one of these, that will now expand out all of the vertices connected to them by those edges that we created. So each one of these will represent a message and a post. And now if we were to do something like this and double click on these users, we would now be able to see, if we relay out with this button in the bottom right corner, we can see that these 2 users are connected by this one post. So we can see that this user liked the post, and this user also liked the same post here in the middle. And we could additionally double click on any of these vertices, and that will expand them out via any edges connected to them as well. And then by relaying that out, we can start to really see some of the relationships between the different bits of our data. Now, there's a bunch of different ways to go through this. We can sort of expand out and traverse along those vertices programmatically using the expand from vertices step, but I'm just going to jump right into queries because those are pretty exciting and they really show the value of graph rather better than I can kind of do just by clicking through things. So we're going to take a look at trying to answer some complex questions using this data in our graph that would be tough to do otherwise. So I'm just going to go ahead. Normally you could write the queries using our write queries interface. You could go ahead, click this plus icon to create a new query and write your GSQL code within here. Once again, like I said, I'm just going to be using the notebook for all of this because it's already here and it's quicker than watching me have to do all of this. So as those go, if we refresh this page, we will see our queries begin to pop up. There we go. So let's take a look at what some of these do. Our first one will tell us, what's our first one? Hashtags from person. So what this will do is we'll start with a person and we'll get us any hashtags that have been in any posts that that person has posted. So we're going to start with a person, go through any posts that they have posted, and then from those posts, we're going to find any hashtags that that person has posted. So we'll just start with a random person, call them 34, run the query, and now we can see this list right here are all of the hashtags that are related to any posts that person 34 has posted. We could see if we run that with a different person, we will get a different list of hashtags. So that's great and all, but that's still pretty simple. So let's take a look at some more things. What we're going to take a look at now is that the one? Yeah, most common mutual like. So we're going to start with a post, and we are going to return the people that are most likely to like that post based off of the similarity of the hashtags to the post that the other person has had. Let me re-explain that because I did not do a good job. But we're going to start with the person. Now let's look at our schema back here. We're going to start with a post rather. We're going to get the person who made that post. And then we're going to look at the posts that they have liked And we're going to see what posts we think are similar to this post based on the posts that people who have liked it have also liked. So we started a post, we go back out to everyone who has liked that post. From all the people who have liked that one post, we find all the other posts that they have liked. And those are the posts that we think are similar to this input post. So go ahead and we'll try that there. We'll start with a Vertex ID. Let's do post 56, if it's a post, and we want to return the 10 most similar posts. So we can do that. Oh, sorry. So this will return, we started a post, we get the people who liked that post, we get all the posts that they have liked. And then from that total group, we look at the posts that were liked by the most people. So this will return post 56 was liked by 3 of the people who liked our input post 56, which is, that makes sense. Post 499 was liked by 2 of the people who also liked post 56. Post 207 was liked by 2 of the people who also liked post 56, and so on. We could change these numbers up and we could see how those different posts are liked by the same people. So that kind of gives us an idea of what posts are similar or what post we could recommend to a user based on a post that they just liked and based on posts that other people who have liked that post have also liked. But we can go one step further. I think actually I need to go a little bit for that. So one thing I will say here is there is a difference. This is kind of pedantic, but there's a slight difference between when you're running queries. So you have installed queries and you have interpreted queries. Interpreted queries don't have to be installed first. You can just run them as you write them. Installed queries, when you install the query, that's when it actually creates the REST endpoint for that query. So all of your queries can be called via REST endpoints, but installing it does take about a minute or 2 just to create that endpoint. And it's also doing some optimization of the query in the backend as well. But what this last post is going to do, or this last query, we're actually going to utilize a subquery for it, which is what I have to install. But what we're going to do is we're going to take a look at what someone has posted, all the posts that they have posted. We're going to get all the hashtags from all the posts that they have posted. And then we're going to take all of our other users. We're going to get all the posts that they have liked. Then we're going to get all the hashtags from those posts. And we're going to compare the similarity of the group of hashtags that one person has liked to the group of hashtags that a user has posted. So from that, we should be able to find users with similar interests based off of what they like, the hashtags of the posts that they like. So we'll go ahead and run this. So we're going to start with a person, start with our good friend 45, and we're going to return 10 people who we think are most alike to person 45 based on the post that they've liked. So we can see person 25 is our most similar with only about 10% of the same liked hashtags, and so on through our different users that we went through. 7%, 10%. Let's see if we can do a little better than 10%. Let's find, I don't know, maybe 56. There we go. So user 92 and user 56 have liked about 13 or 14% of the same posts. And we could actually verify this. So what were those numbers? 56 and 92. I know I'm going a little bit over time here. I apologize for that. But if we go into our Explore Graph tab, we can find paths between 2 vertices. And I could say person, I already forgot the numbers, 56 and person 92, was it? And I can show all paths. Maximum path length, we'll say, is going to be, this actually won't do what we're trying to do because it is, this doesn't go through the hashtags. I could set it up so it does, but for now, this will just find all of the links between these 2 people. So these will find the similar posts that they've liked. And if we go ahead and relay that out, it'll look like a mess because it's very densely connected. So yeah, sorry about that. There will be a recording of this available. There's also a pre-recorded version, which is a bit more concise, and both of those will be linked out afterwards as well. I'll quickly grab some Q&A right now. Once again, I apologize for being over time, but I will just scroll through this list and see what we have. Is there any auto conversion from traditional database to a graph database model? I'm very glad you asked, and there is. And you can do that through, where is it here? We do have a, somewhere here, there's a setting for just importing a SQL database into Graph. We do have a importer there for that as well. Data include rich image types. It cannot. Graph is really optimized sort of for speed. So all of your data is stored in RAM. So it's you don't really want to be throwing in things like images or photos if you're going to be doing that. It is perfectly fine, however, to store all of that in like a S3 bucket or some other form of blob storage and have links going back from your data set to that more traditional storage manner. So is it important to identify the relationship type explicitly in Graph, e.g. one-to-many, many-to-many? No, it's not. That will be, your Graph will build that out. As long as you define in your schema that, vertex type person relates to vertex type post. If there's 30 posts from one person, that's perfectly fine. If there's only one post from one person and it's one-to-one, then the Graph will take care of all of that for you. Can global and local schema collide? Yes, they can. Let's see. Any way to get control deleting duplicated data? So here's the best part. TigerGraph upserts data. So there is no such thing as duplicate data in TigerGraph. If you have a vertex, say with the ID of 1, a vertex type person with the ID of 1, and you upload another vertex of type person with ID of 1, that new data will overwrite the existing data where it is different. So if I wanted to update a user's email address, I would just push that full vertex of the new user, and that would replace the old user with that new email address. If you wanted to keep track of those changes, there are ways to do that. So that way you can kind of maintain that history. But for the most part, when you insert your data, it is an upsert. If it does not exist, it will be created. And if it does exist, it will be modified. Is there a Java GSQL client library? There is. You can check out, we have a list of all of our GitHub. We have a bunch of, all of our connectors are on our GitHub page. We have TigerGraph ecosystem is our ecosystem pipeline. So here you can kind of find any sort of connectors or tools that interact with TigerGraph. How can I load data from a Spark data frame? So I haven't used Spark much, but through Python does natively support Pandas data frames. Our TigerGraph connector library does support Pandas data frames. I'm not sure how similar Spark data frames and Pandas data frames are, but if you can get your code into Python, you can load in those data frames through there as well. The Python library also supports the ability to pull data out as a data frame. So if you want to then take your graph data and integrate that into your machine learning project, you're good to go. You just write your query, it'll export your data as a Pandas data frame, and you can just you do whatever you want from there. So yeah, so that's kind of, sorry, went over a bit. This is a very quick introduction. Throughout the rest of the series, we're actually going to be building up a much more complex real world data graph, and we're going to take a bit more in-depth look at exactly what the data cleansing process looks like, what the schema design process looks like, and kind of what it looks like to map and load all of that data when you're going to be using something that is a bit more than just some machine generated CSV files to represent fake data here. So that's what we'll be doing in the rest of it, kind of going from, here's what you need to start playing around to here's what you need to actually build a production graph solution. So thank you all for attending, and I look forward to seeing you all in future sessions.
Thanks. And Dan, we have one more quick question in chat that just came out.
Okay, so best practice for storing time series data. There we go. That's a great question. So time series data in graph is, I wouldn't say it's tricky, but it's not as intuitive as you might think. So typically you want to relate events. You kind of want to create a chain of events. So if you have an event, then you would then have an edge that says next event. So I guess that's one of the things I didn't cover here, but there is nothing preventing me in the schema design from linking a person back to a person. So say person was friends with person. could easily do that. So for example, I guess in the context of what you're asking, I could do post. I could say, like next post. And that would establish the chronological order within all of my posts. So that way I could see that I made a post, I can traverse that next post edge, and that will bring me to the next chronological post that was created. Additionally, another way to do time series as well is to have a date tree. So you would have something like we'd have a vertex for things like hour, day, week, that would then be related back to each one of your posts. So post, and you would say like on hour, and then you would relate that back to on day, on week, in year, and so on. So now you kind of have the ability to say, find me all posts from this hour on this day of the year, and you can get all that more information as well. So yeah, hopefully I answered those questions. Hopefully I didn't bore anyone with all of this. I know it was a bit quick and maybe a little technical at some points, but I swear I will break it down a bit more over the next couple of sessions and hopefully make everything much more easier to understand and hopefully help people get started with their first graph solutions. So thank you all again for attending.
Yeah, thank you all so much. We'll follow up with an email with all the information and the document Dan shared, and then be sure to come to the next 3 sessions like Dan mentioned. And thank you again. Have a good rest of your day.